welcome to All Things Indian Friendly Voices. This is episode 8. Today we are going to discuss something which is part of our life, almost intricate part of our life, almost 24 by 7. This is something which it is with us. It is part of, without that, our life will not be completed. Again, that's a fate of, or maybe the characteristic or trait of humanity that we never think about. We never try to know anything that's part of our life. Like Jiddu Krishnamurti said, truth is in our everyday life. But, we never pay attention to everyday life. We take it many things for granted. The thing which I'm referring to today is power, electricity. Well, without that, earlier, maybe 100 years ago, it was seen as a luxury. Today, it is part of, it's almost, without that, it's almost become indispensable. And how electricity is produced, how it is transmitted, and what are the issues involved. Well, at least I don't know. So I'm here to get myself enlightened about it. We have a wonderful, very friendly, wonderful friend here with us, who is a very knowledgeable person.
Yeah, so let me introduce Mr. M. Rajagopalan. For those who are on Twitter, he is known as Chennai Karan. Those who are not Tamilians may have read him as Chennai Karan. His name is not Karan. It is Chennai Karan. That is, he's a denizen of Chennai. His name is M. Rajagopalan. Now, Mr. Rajgopalan was a chemical engineer by training. That is, he passed out chemical engineering from the University of Madras. But after that, he has been fully into power engineering for the last 4 decades or more. So the first 2 decades, he has worked with an American MNC, basically marketing industrial equipment. And then the last 2 decades, he has been with a Finland-based MNC in the power sector. And in last few years, he's been working in a much wider area, which spanned Middle East, Asia, and Australia, basically on power system modeling and support system planning. So this gives him a very good idea about what is involved in transmission of power, what is involved in us obtaining different alternate sources of power, what is clean power, what is unclean power, and so on. So he is in a very good position to answer our questions on how this whole idea of power is intricately related to our growth as a country. So powering India is what we would have the topic of the discussion today. So let me formally welcome Rajagopalan. We call him Raj for short. So welcome, Raj, for the show. And I will let Rajmohan start the conversation. Over to you, Raj.
Yeah, thanks, Suresh. And it's our pleasure, sir, to have you here, Mr. Rajagopalan. And just now Suresh said it's about growth. And today it's power, electricity is part of almost all jobs. And that means any kind of a growth of all fields, all sectors, means it inevitably involves electricity. So don't you think that how economy itself, the growth of economy itself in one way, most probably directly involved with power?
That's right. First, thanks Suresh and Raj for inviting me. I thought I should have 2 qualifying statements to begin with. One, this power sector is such a huge field, and I have been a fringe player in a non-core area of the power sector. So I can't claim to have a knowledge of the entire sector. I'm always reminded of the 6 blind men of Hindustan and the elephant, each holding on to a part and imagining that they are holding on to the entire animal. So that's the first,
Yeah.
first one. The second one is a statement by Mark Twain. You know, the more one ages, the more vividly one recalls events that haven't happened.
Yeah.
So,
Yeah.
I would like you to remember that, especially when I quote some statistics. Most likely they are wrong. So with these two qualifiers, let me get going. See, when you talked about growth of a country, you know, what is a defining characteristic of a developed country? I mean, there are many things that go into that definition, but one very important characteristic is that people in those countries take availability of electricity for granted. You know, whether it is the US, Singapore, Europe, everywhere you go, there is no such thing as power cut. It's a reportable incident if it happens, right? It may be due to some natural calamity like in California or Australia, but that is something they need to take for granted, 24 by 7, as you put it, Rajmohan. We find that there is a two-way correlation between GDP of a country and the electricity consumption. As obviously, you know, electricity is an enabler because it helps in manufacturing, services, mining, you know, everywhere it helps and helps the country grow its GDP. Conversely, as the GDP increases, the standard of living goes up, and then the demand for electricity again goes up. So you find that they are in step most of the time. So we call it a two-way causation. So each spurs the other to grow, right? Now, if you go by some statistic, if the world average of per capita electricity consumption, I think it's around 3,000 units or so per year. India is very low. It's hardly 1,000 plus units. USA is about 12 to 15,000 units. And somebody like the UAE is about 18 to 20,000 units. That's the kind of gap there is between a developing economy and a fully developed economy. And electricity plays such a key role there.
Yeah.
Yeah. So I initially, wanted to ask you about this two-way correlation, which you already have answered. Now, my question to you would be that, I remember, when I was flying back once from Frankfurt to Bangalore, that we passed over probably Saudi Arabia, and I could see for about half an hour or 45 minutes, which on a flight should have been close to 400, 500 kilometers of an highway, completely light. I mean, the road was completely lighted. You could see from the air, and the night was nighttime. And I think it's about probably 45 minutes or an hour, which means that, you can have 700, 800 kilometers of highway lighted, right?
Yeah.
So what steps has sort of Indian government being taking to address this sort of, we have definitely not, we don't have electricity at that levels, as you said, consumption. Again, okay, let me ask you this way. Is it because of the lack of electricity that we are not growing, or is it because we don't have the sort of growth that the country is not producing that much electricity?
I think a little of both, obviously, because when you say there is a two-way causation, and it's been evident in many of the developed economies. So I guess non-availability or inadequacy of power certainly came in the way of your growth, the growth of the economy, and conversely that affected investments in the power sector. See, some of us who grew up, in the 80s and 90s, we remember the days of power cuts, inadequacy of power. So those of us who joined the power sector those days, the cry was we need to have adequate capacity of power. So at whatever we need to do to build more capacity, right? That's what we need to focus on. So what did we do? Country had enough of coal, right? So we thought let's look at coal-based power plants and start building coal-based capacity, right? So that was the mantra those days. So you're right, adequacy of power. That was that was a crying need in the 80s and 90s. I think, to be fair to the planners, the situation is a lot better today. As early as, as recent as 2002 and 3, there was a shortage of 15 to 20%. The difficulty in the power sector also is, how do you define shortage, right? So because if I don't have enough electricity to supply, so once it reaches a certain limit, any demand beyond that is not served, right? So that unserved demand, how much is it? There is no scientific way of measuring that also.
Okay.
So we said, okay, it is about 15 to 20%. And there are two ways of measuring the shortage. One is what they call as the energy shortage, and the second is what they call as a peak shortage. Peak shortage could be, see, every day at about 9 a.m. you have a peak in demand. Similarly, at about 6 p.m. there is a peak in demand. Take Bangalore; it's typically peaks at about 5:30 to 6 in the evening. Now that is measured in megawatt, right? And if I'm not able to meet that ramp up in demand in the evening, we say there is a shortage in peak demand. But we talk about energy shortage in terms of 24-hour supply. So that is measured in kilowatt hours or megawatt hours. So it is the average, not the average, it is the total number of units consumed per day. And if I'm not able to supply 10% of that or 8% of that through the day, then we say there is an energy shortage. So coming back to your point, early 2000, that figure was something like 10%, 15% on both peak and energy shortage. Last year, that figure has come down to about 0.5 and 1%, right? In terms of capacity availability. The last mile connectivity issues still remain. You still may have power cuts in your area because of transformer issues. It could be because of some other transmission related issues, right? So those things are still there, but capacity wise, I think we have created enough buffer in our system so far.
Okay, I mean that's interesting because I have seen both, like what the phenomenon which Suresh is referring to. Whenever we land in 2 a.m. or 3 a.m. in any of the airports, and then we go, and the utility of power is almost there on 24/7. But on the same time, we go to village near Ayodhya, or in Chhattisgarh, or in Bengal, any other place. There's no electricity at all. Now, when we talk about adequacy is that in some there are, from as a layman, what I understand is that there is a hydro, coal, wind, solar, etc., etc. Are we not into all these things, or all these means by which we generate electricity, or we are still dependent on coal by and large?
Yeah, good point. You see, when it comes to villages, I mean, you made a point about, when we talk about demand, we are talking about demand from already electrified entities. Now, if some household is not electrified and there is no demand, that is not counted. That is unfortunate. But it has been recognized. So what has happened is, in the last 4 or 5 years, it was stepped up, and today we can claim that almost all the households in all the villages are electrified. There was a time, even the definition of an electrified village was so absurd. Before 2003, when we passed the Electricity Act, the definition of an electrified village was if there is one bulb in the village, right? One house with one bulb in the village that was deemed to be electrified. It was as absurd as that. Whether or not it got electricity connection, that is different, right? The after 2003, they said, no, this is ridiculous. So it was slightly improved, not too much. I think the act said that electrified village is one where at least 10% of the households are electrified, and at least some public institutions, maybe a public health center, hospital,
Panchayat
panchayat
office.
level hospital, no, those need to be electrified for the village to be deemed to be electrified, right?
Okay.
And I don't, and then somewhere in 2009 or 10, they said, no, let us aim at electrification of all villages. And I think it gained momentum in the last 4 or 5 years. And today, at least the claim is there is 100% electrification. At least the connections are there. Whether physically the electrons are flowing to those households, we don't know, right? Mm-hmm. So even the definition was wrong till about a few years back. So that is one reason, Rajmohan, that when you drove past the villages in Chhattisgarh or Bihar,
yeah,
there's no light because there was no power connections at all. Those villages were not electrified. You know, ironically, I've been to power plants, and as you come out of the power plants, there are some villages and you don't have power supply. I mean, they're just outside the power plant. So from the power plant, the power goes away via transmission lines to serve people in Bangalore, maybe, right?
Yeah.
But the villages outside those power plants, within sighting distance of the power plants, they are not.
No, that's, that what you're saying is in the last 5, 6 years, we have ramped up, and then almost all the, you say 100%, because there are 6.5 lakh villages, or there even, let's say, proper villages of 4.5 lakh villages. That's a mind-boggling how much of, how they have been, we can reach out to those villages, 10% of those villages, and then electrify, that kind of electrification would take almost, I don't know, even with today's technology, it will take years. How did we reach there?
No, actually, it was done in phases. Obviously, the low-hanging fruits, those villages which are easily accessible, off the highway, those were covered first. It's only the remaining 18,000 villages, if I remember the number right, which were covered in the last 5 years. And these 18,000 villages were typically which were not accessible. It could be because they were in places in Kashmir or Himachal where there was a lot of snow. Sometimes they were in, let's say, Maoist-infested places, right? Or it could be in some terrain where laying power lines was just difficult. So they took a practical view and said, okay, in these villages, let us look at off-grid solutions. You don't need to lay transmission lines. Let's look at solar panels in those villages, right? It is a compromise, definitely, because it is extremely difficult to provide 24/7 power. So what you're telling the villagers is, as a first step, at least get power supply for 3 to 4 hours a day, right? Get used to the fact that you will have electricity, and then gradually we'll build up the power supply. That's how it was completed.
No, but my main question was, are we not into all kinds of means of generating or producing electricity, hydro, solar, coal, or are we still dependent on coal?
Yeah. See, for historical reasons, we've been highly dependent on coal. One, of course, coal is ubiquitous. It's available in plenty in the country, right? That is, it can, they say that we have enough coal to last us for the next 250 years or so. So that's one part. Second is the price is within our control, right? We can fix the price of coal and supply to the power plant. And so it doesn't have to depend on the market vagaries, right or wrong. There is no market discovery mechanism for these prices. Third, nobody factors in the social costs, the health costs, the environmental costs of using coal. So somebody says using coal costs me only 2 rupees a kilowatt hour. It's very cheap. So let's build more coal plants. So with the result, what has happened is out of our total installed capacity today, 60 to 70% is still coal-based plants. And out of the total generation today, nearly 80%, I would think 80% of the generation is from coal-based plants, even today. But we do have a better mix now. I mean, we have hydro in many parts of the country. You have it in Himachal, you have it in parts of UP and then Uttarakhand, Arunachal Pradesh. Karnataka has quite a few hydro plants. The problem with hydro plants is obviously that it's seasonal. It's very dependent on monsoon. It may be there for a few months in a year. And the second thing is it is irrigation linked also. There is a political compulsion to release the water for irrigation. So synchronizing the two things, irrigation and the power need, is quite difficult. You know, which do you prioritize? So the farmer lobby will want the water, right? And so you release the water maybe, you know, when the power demand is not there. So managing that is quite difficult. Still, hydro gives you about 10% of the total power supply in the country. I would say coal is about 70 to 75%. Your solar and wind today has increased to about 7 or 8% in generation terms. I'm not talking in megawatt terms. Because if you talk in megawatt, it can be misleading. We have totally, I think, around 370,000 megawatt of installed capacity. But our peak demand seldom crosses 175,000 or so, right? That's because, why do you need 370 then? Is it because of inefficiency? No, it's because there is a lot of solar, a lot of hydro, a lot of wind, which is not available 24/7. Only the coal is available 24/7. So to answer your question, Rajmohan, yes, we have been very, very dependent on coal, which meets about 70 to 80% of our power needs even now. The other aspect is that there is a thrust on renewable energy coming in, right? So which means that gradually the coal has to give way to renewable energy, but it's going to be a very slow process.
Yeah, Raj, once, I was just traveling from Delhi back to Bangalore after some work. There, next to me was sitting a girl who was working in TERI, the Tata Energy Research Institute, and we were speaking. And she was explaining a lot of things about power and all that. And she was telling me that, nuclear energy is supposed to be the cleanest energy of them all. But unfortunately, for various reasons, there seems to be a complete backlash against nuclear energy. I do not know how it is in the other parts of the world. So how does the capacity that India generates through nuclear power compare to that which is generated by, say, the advanced countries like US or, say, Japan? Of course, that because of that Fukuyama, I think, right? There was this leakage. And of course, Chernobyl is a very popular problem that we have. So how do we compare in terms of nuclear power with those of the more advanced countries?
The nuclear capacity is quite low, right? I think in generation terms, I doubt if it will be more than 2 to 3% of the total power supply in the country. You're right about the fact that it's one of the cleanest forms of power generation. When you say clean, I'm talking about CO2. That's the word used today. So there is, if you're looking at carbon emission, I mean, nuclear is up there with solar or wind because there is zero carbon coming out of that. So to that extent, it's a very, very clean fuel. But of course, there is that bogey of there is that fear about nuclear in people's mind, which a lot of activists bring out, or even, I mean, if I can use the word, they even exploit that. Take the case of what happened in Kudangalam in Tamil Nadu. Before the 1,000-megawatt plant could be commissioned, activists stopped the construction, stopped work on that. It took many, many years for that to come online. Because investments in nuclear, upfront investment costs are very high. If there is a risk from the activist front, people will hesitate to invest, right? Why would I invest? Let's say nuclear could cost about 15 to 18 crores a megawatt. Compare that with coal at 8 crores a megawatt, or wind at some 6 crores a megawatt, right? Even though nuclear gives me clean fuel and it gives me fuel gives me a 24/7 power supply, I'm still wary of the investment risk on that plant, right? So it's more political. And of course, there is, you have to admit there is a small risk about the handling of the waste fuel, which is a problem for eternity, right? So you've got to take care of that aspect. And in a democracy, you're making a Faustian bargain, really. That okay, in return for the clean and cheap power, I undertake to take care of this forever, the waste fuel forever. Okay. So that's the reason people are hesitating. And if you can, let's say, get that same amount of power with sun, wind, and energy storage, battery storage, for example, in the future, and that's the direction the world is taking, probably it carries lesser risk than nuclear. That seems to be the mindset today among all developed.
But what about the developed countries? How much do they depend on nuclear fuel? Nuclear power.
Even Japan, which was ravaged by the nuclear
leak.
Not only nuclear leak. They remember
the atom bomb. Yes,
aftermath of Nagasaki and Hiroshima. Even they set up a lot of nuclear plants, right? And 30 to 40% of their power supply came from nuclear. But due to public outcry, a few years back, they said, okay, slowly we are going to close down all the nuclear plants and replace them with either gas or coal plants or renewable energy in the future. Same thing happened in South Korea, right? They also closed down all the nuclear plants. But then when it comes to reliability, they are very tempted to start the nuclear plants again. And recently I read that Japan has started nuclear plants again because gas pricing has been very high. So they said, we are not going to be blackmailed on gas price. Let me restart the nuclear plants. Right?
Oh. Okay.
Yeah, and some countries like France, nearly 70% of their power supply comes from nuclear. And their carbon emission is much, much lower. Carbon footprint in France is much lower than Germany, which is very hyped up. You hear about Germany's solar and wind and their energy wind and all that. But actually France with nuclear, the carbon footprint is much lower.
Okay.
Okay. So that both of a little bit I take off from what Suresh said. Okay. Now you said the various ways and how India is still fairly dependent on coal, and Suresh asked about nuclear and renewable energy also. But the other side of it, people like me who are no way related even to science or mathematics, we don't know how the produced electricity is being carried, how it is transmission. Power transmission is something most of us do not know. And all that we hear in news or maybe somewhere in channels, they mention grid failure. We don't know. It's all beyond all of us. How actually the produced electricity is being transmitted to various spots.
That's a topic for a separate call, but if I can summarize it in a few words, see, whatever is the form of generation, whether it is coal or nuclear or wind or solar, ultimately the output is you want to get out a few electrons, right? And then you want to step it up. Why are you stepping up the voltage? Because it's easier to transmit it through long distances. So if I'm producing at, let's say, 415 volt or 11,000 volts, the losses will be very high if I transmit it over long distances. So typically, I will have a transformer in my plant. I produce power at 11 kV or 110 kV, and then I step it up to 220 kV or so. And then I can send it from, let's say, Raichur or Sharavati. I can send it to Bangalore, 300, 400 kilometers through these transmission lines. And then I step it down again. I mean, when it reaches your house, typically it is at 415 volt, right? Even a three-phase supply is at 415 volt. So again, there are step-down transformers, which bring down the voltage, and then the electrons reach your homes and then light up your lamps, power your television sets, your refrigerators, your washing machine, etc. So this is what happens in electricity system. Now, what we are trying to do is we are trying to connect, like the internet. We are trying to connect all the power plants, right? All the transmission lines on a common frequency, right? So that the power that I produce in plant A can be transmitted anywhere else in the system. It need not be only a bilateral power supply. So it can be a shared resource, right? So let's say we have 10 500 megawatt plant, 5,000 megawatt grid can be created, and this can be channeled and distributed to different households, industries. So that's what we call as a grid. The grid is one which is synchronized with on a common frequency, right? And then every power plant in the system and every user in that system is connected to that grid.
Okay. So Raj, this leads me to an interesting question. See, when you're talking about a grid, it then becomes a sort of a national grid is what you're talking about, right? It is, so the power can be generated in Bokaro or Ramagundam, for example, or Kottagudam. And from there, it can be transmitted to anywhere that you want on the grid. While that seems to be a good thing, one concern which people may have is, I've been to Himachal a few times, and even the remotest village in Himachal, I have a friend who runs a lot of resorts there. He told me, in Himachal, you set up anything. If you are Himachali, you build a house, you set up your resort, do whatever you want. The moment you do and inform the government, wherever you are, the government will bring a line into your house. I mean, Himachal has that reputation. So this guy is from Delhi. He used to say that in Himachal, about power, you don't worry. Anywhere you want to set up anything, the government will pull a line into your place. So if this is a national grid, then how can each state ensure that, it gets adequate power that it needs? Now, if I'm not mistaken, each state makes some sort of an agreement with the concerned power plant or something like that, right? Is that how it works? How does it work in India? Like, how is a power a state thing where states buy power, or is it always allocated by the center?
No. It's a little more complex. See, electricity is what they call as a concurrent subject. Okay. Certain broad policy decisions are taken by the center, but the state is responsible for the power supply and power distribution, everything. So state is the unit which is in control.
But not power production, right? State is mostly for distribution.
Yeah, it is like this. Till a few years back, let's talk about let's say 70s and 80s. All the power before the privatization, I'm saying, all the power plants were built by the state governments, right? It was owned by the state government,
Ah, I see.
right? But the central government also built some plants through agencies like NTPC, for example.
Okay. Okay.
Built the plant, and then if NTPC put up a plant in Ramagundam, there was a power sharing formula. The 1,000 megawatt plant in Ramagundam will be shared by Andhra. Andhra will get 500 megawatt, Karnataka will get 100, Tamil Nadu will get 100. So it was apportioned that way. Only the central plants, right? But the state had a PPA with those plants and then bought the power from them. But I would say 60 to 70% of the power was supplied by the state-owned plants. The next phase, sometime in the 90s and early 2000, state governments entered into power purchase agreements with private parties. They invited private parties to set up their own plants at their own cost, and then entered into long-term agreements with them, undertaking to buy the power at a certain price for the next 20 years or 25 years. So to answer your question, the fundamental responsibility still lies with the state government, right?
Okay.
For taking care of the power supply within its, and even the load, what they call as a load dispatch center, which actually strikes the balance between the supply and demand. It is a load dispatch center that manages that. An interesting thing about electricity, sorry to digress here, compared to many the most other commodities, right? Electricity is not stored, right? Except for small battery storage, which is still not very large. So the minute electricity is produced, or the second, I would say, it is also consumed. So there is no inventory in the system. So it is consumed in real time. So it makes it an excellent indicator. For example, I could compare pre-COVID and post-COVID, what is happening, right? If post-COVID, the power consumption has gone up, it is not because some inventory is getting cleared, like in the case of cement or trucks or automobiles. It is because there is a ramp up in production, ramp up in power demand somewhere. So it's a very, very clear indicator. Electricity is a very fascinating indicator. It tells you the story right away.
Okay. So, yeah, so Raj, here I will just follow up with one more question here. Since you brought this up, this is something which has also fascinated me. As you said, we don't have really storage anywhere. I mean, whether it's India or in the world, we can't really store large amount of electricity, right? Except some batteries, but they don't store a huge amount of electricity.
Not yet.
So, yeah. So essentially, this will mean that the control systems are designed such that depending on the demand, automatically the production is varied, goes up or goes down. Is that it? First question. Second question is like, all this thing of, the world, whatever environment day we shut down power, all of a sudden everybody does. And now in the COVID time, we had this closed down 15 minutes type of a thing. Now, would they also place a burden on the distribution system and the production system? So these two questions.
Yeah, absolutely. See, like in economics, supply demand, what balances it out is the price, right? Price can go up and down to balance the supply and demand. Similarly, in electricity, you have factors like frequency and voltage. So if the demand exceeds the supply, then you will have a drop in frequency, which is immediately sensed by the system. So there is a band, frequency band, which is considered optimal or considered safe. Earlier, we used to allow a wider band. Now the band is, okay, if 50 hertz is the desired frequency, we are talking in terms of 49.9 to 50.1, very, very narrow band.
Okay.
So what happens is if it drops below 50, there is also a mechanism by which whoever draws more power than what they had scheduled how it works is the previous day, every user, every undertake, I mean, user meaning not you and me. I'm talking about the power distribution.
Distribution centers, okay.
So somewhere at about 5 p.m. every day, they give a schedule of consumption for the next 24 hours, saying that for every 15-minute time block, they say at 6 a.m. I'm going to consume 2000 megawatt, at 6:15, 1900 megawatt. Now, if it happens that at 6:15 you had scheduled to draw 1900 megawatt, but you are drawing 2000 megawatt, and at that time the frequency is dropped to 49.9, you will be penalized, right? You will have to pay some penalty for that. That is how the system balances itself, right? And it works even in free markets in places like Australia or California or the UK. The price discovery happens on the spot. It happens every minute, right? And it works perfectly.
Okay, but what I meant was that there must be an appropriate control system mechanism, right? Where if you're drawing lower power, the production of power has to be low and yeah.
So the second thing is if you're drawing less power than what you had committed,
Right.
the frequency is going to go up, and somebody has got to cut down the power supply,
Oh,
right?
okay.
And there is limited flexibility in the system. Now I can ramp, if my coal plant is running at 80% load, I can cut it down to 70%. I can cut it down to 60. Below that, I'm slightly nervous. I can't cut it down below 50%. Running on, there is a pressure on my boiler, on my turbine. I can't cut it down. So what will happen is I will start curtailing power from other sources. I'll cut down hydro, I'll cut down renewable. And this is how the load dispatch center has to manage every minute of the day,
Oh, okay.
And then you asked a question about events like, the famous event where the country was asked to switch off the lights just when the COVID started. I kept track of it, how the power was dropping. The power demand dropped by nearly 30% or 40% in Delhi alone.
Oh, okay. Okay.
Now the complete power system guys were on their toes for nearly 48 hours prior to that. They had to plan for the event, and they had to make sure that a lot of hydro plants had to be started. Hydro plants are very flexible, they can ramp up and down much better than coal plants. So they at some point, they increase the hydro, they reduce the coal, and then manage the system. But they were obviously under a lot of stress. So the system is not very flexible to handle a lot of variation.
Oh, okay.
It's a certain band. In that band, yes, it can be managed well.
Okay. Raj, you may have to slowly tilt a bit camera so that your face is more fully visible.
Is it better?
No,
slightly more. Tilted. You're better. This is better. Yeah. Thank you.
So no, that's very interesting. I mean, from a layman, I say any energy that is produced and transmitted from a particular source to particular destination, there must be some kind of a shedding, some kind of a loss somewhere along the way. Okay, is it like something like it goes away? What happens to that? Because the way I'm asking this is a lot of us who are from economics, psychology, sociology background, we could not understand some 5-6 years ago. There were very interesting course on what is called fourth generation. I don't know. Is it just whatever? We don't know scientifically what that means. But is it something like at source when the electricity is produced and some kind of a wastage is there, and using that wastage again to put it back into the system or something like that? Or what happens to that? Because affordability, you mentioned affordability. The loss of energy also taken into account while calculating the price.
Yeah. I mean, see, the transmission losses, it has to be seen two ways. One is there are the technical losses, meaning when electricity flows through wires, it produces heat, obviously. And when it produces heat, that amount of electricity is wasted. We call it the copper loss. And so that could be, in a good system, can be below 7 or 8% of the total thing produced. The second aspect is theft. You know, it's a reality in India. In the distribution lines, a lot of electricity gets stolen in many ways, right? So earlier they used to call it T&D losses, transmission and distribution losses, which meant just the technical losses. Now they call it AT&C losses. I think uh, accounting something, transmission and so what it means is they calculate from the minute it is generated, amount transmitted, amount billed, right, and amount collected. Amount collected for how much, how much of electricity. So now you know where, and this is done in each circle, right, distribution circle. So no, you know exactly where the theft is happening. You can narrow it down and say that this is the area where the losses are happening. It could be a technical loss, but more often than not, it is some kind of pilferage that is happening, and so that needs to be looked into. So that auditing is possible today.
Okay.
Over a period of time, gradually we have brought it down to a more reasonable level. There were times when we were talking of 30-40% losses, right? And now it's much lower. I don't recall the recent figures, but I would think it's closer to 15% or so.
Okay, because I have some related question that maybe look silly, but manually it is very impossible to manage such a large network of electricity generation and power transmission. So some kind of automation, software guys, industry is deeply into it.
Yeah, it's basically data analysis. Data analysis is, I know very clearly how much is generated, right, at the power plant. I know how much is consumed within the power plant. So I know net how much power goes into the system. And I know how much is received by the distribution circle, right? It is metered there. At every stage, it is metered. So with all these data points, I can certainly find the pattern. Where is the loss happening? Which state is more? Which circle is more? Where should I focus on? So it's not just control, it's data analysis in real time happening.
Okay.
Yeah.
Yeah. So, Raj, another thing which you already had touched upon, which I thought I'll ask you to expand, has been about the alternate forms of energy than coal and hydroelectric, right? The renewable energy, as we call, probably solar and others, wind energy type of things. So, what could be the drivers towards this? I mean, why would a country want to go to something like solar energy, which, as you said, may not be capable of delivering 24/7, but could act as an alternate for some time, or wind energy again may not be 24/7. But what are the drivers which are driving, say, some country like ours to these sort of energies, and how practical it is? I mean, what are the things that government now speaks a lot about solar, what they want to do, what levels do they want to reach, and is it practical at those levels?
Yeah, it started, let's say 10-15 years back. It started as, I would say the driver is to have cleaner energy, right? I mean, carbon emission wasn't in fashion then, but it started with this imperative that let's have a cleaner form of energy, and it was very expensive. I mean, there was a time when solar energy used to cost somewhere around 15 rupees a unit. I remember the first PPA that the Modi government in Gujarat signed as part of a solar park there. It was around 15 rupees a unit, and that's still being paid, right? compare it with the recent prices of 3 rupees and 350. That's the norm today. So it started with that. Clean was, that is the driver. But gradually it became cheaper too. So today the driver is, it's genuinely cheap power. It is cheaper than many other forms of energy. And from last 2-3 years, it is cheaper than coal, right?
Oh.
So yeah, it is. I mean, when you auction it out, you're getting a price of 3 rupees and 340 and 350, right? So, I mean, that is a clear driver today in all over the world. Same thing with wind. Prices have come down. The capacity factor of many of the windmills have become taller. It is able to capture more of the wind, so its capacity factor is much better. Therefore, it is cheaper also. So price obviously, right, is important. So how practical it is now, obviously, as standalone solutions, you can't depend on solar and wind. Sun doesn't shine all the time and wind doesn't blow all the time. But you can have a combination, right? Solar and wind, where you can have windmills in Chitradurga, solar in Gulbarga, and together, they may have a better capacity factor, right? You may have wind in the night and solar during the day. Now, the batteries are emerging as a very interesting solution. So we believe that, let's say 5 years, 10 years from now, batteries storage will not only become more cheaper, it will scale up adequately so as to be able to store a large amount of solar and wind energy. And most countries are betting on that to happen.
Okay.
So India's plans are quite ambitious. I think what we had said was we want to increase the total renewable energy to about 175 gigawatt by 2022. I doubt if we'll reach that figure, but even if we reach 100, 120, it's a good figure, right? The second thing that it will enable you to do, let's assume that your electricity from the grid is predominantly renewable energy. It cannot be 100%. Let's say it is 30%, 40% renewable energy. Then when you bring in electric vehicles, right, you change it from petrol, diesel to electricity. You can be happy that the electric vehicles are drawing clean electricity, right, to get charged.
Okay. Okay.
And then the railway ministry, it's emboldened enough to convert all the diesel engines to, not convert, they want to make all the engines as electric locomotion, right? Within 3-4 years, it's going to be almost 100%. How are they doing that? They believe that enough solar and wind energy will be available, right, to power the train. So nobody is going to accuse them of running electric trains with coal-based energy, dirty form of energy, right?
Okay.
So I think it's practical, and they seem to be committed, and it seems to be economical also, judging by the drop in prices all over the world.
Okay. So Raj, just as a follow-up on this, so all these forms of energies are also sort of fed into the national grid, right? Not that they are separate and they have a separate grid or something like that.
No. There are two ways of doing it.
Okay.
You can put up a large solar plant, right? It can be spread over acres and acres. There are solar plants which are even in Karnataka. I think the largest plant is 700 or 800 megawatt, spread over about 5,000 acres of land. These are all connected to the grid, and then the electrons flow like in any other form of generation. The other way they are trying to do is, at least part of the 175 gigawatt is from local decentralized solutions, which means solar panel in villages, solar panel in commercial buildings, right? Above parking lots, you can have these solar panels, right? So that can also give you solar energy.
Like individual houses, for example, a lot of
Exactly.
individual houses.
Exactly.
Okay. So these sort of smaller things are not connected to the grid, but the larger windmills and this are.
It can be connected to the grid. There is a smart metering system possible wherein in places like Australia and Germany, it's working very well. And in some of the states in India also, they've tried it. So if you have a solar panel, let's say of 1 or 2 kilowatt power, you can be connected to the grid. So whenever you have the panel producing power, you consume that. Whenever panel is producing power and you don't need the power, you export it to the grid. The meter picks it up. Whenever it's not available, you draw power from
the normal grid.
From the normal grid. So it's called the net metering. So that is possible. Yeah.
So you are charged based on how much you gave to the grid and how much you took from the grid.
So you're charged based on the net metering. Yeah.
Okay.
Okay. So just you have to tilt again the camera a little bit down. So yeah.
Yeah. That's
so we are running out of time. One question from me, final question, and then Suresh will conclude. Basically, there was some interesting ideas, some papers, some maybe 7-8 years ago. India has got a vast coastline. And then people are saying that you can have a combination of three. I don't know how that will work, whether it's possible even in theory. Windmills, solar, and tidal. You can put all of them and then just pass on the electricity. Is that a very viable solution?
See, I would say, I mean, you can always produce electricity from waves. I mean, it's a proven thing. But once again, it's the economics. If I can do it from solar and wind at a much cheaper rate, why would I get into the risk of going in for other forms of energy, right? They claim that wave energy can be 24/7 as compared to solar and wind. But so far, the economics, it's not a compelling case that I have seen. So I would put my money on solar, wind, and battery storage right now. I mean, based on the prices that I see in the marketplace.
Okay. Right. So as Rajmohan said, we're probably running out of time. So let me conclude here first by thanking Raj for this wonderful illuminating talk. Now, so in conclusion, what I see is that there is a very close linkage between how a country grows in terms of its GDP with power. So more power consumption to a very large extent leads to a greater GDP growth, and greater GDP growth increases the demand for power, and you want to get power. And from the point of view of India, from an earlier time where we had power cuts, most of the time, a lot of us had faced 12-hour power cuts and more. Now things have progressed quite well, where power cuts are far lesser. And as Raj says, power cuts are not due to lack of electricity, but it's more to do with your local transmission and distribution issues than of the power. There seems to be adequate power to power most of what is needed. Again, Raj also made a point that while the whole capacity that we have today can be consumed, probably, we do not know what exactly is needed more, because they're not real scientific ways of measuring the unknown demand, right? The known demand is fully measured, and we sort of, that metric can be used to see how we are able to deliver that sort of a requirement. But what is not there, we still have no really scientific way of measuring it. But one thing is for sure, we need to ensure that the power production, distribution and all keeps going up as our GDP is bound to grow up. Anyway, I mean, we know that it's in a different situation today, but that's probably a temporary one. And then as the GDP grows, we will have more need. And then we have also spoken about the renewable forms of power. And Raj has now made a point that power like the solar power have become very affordable. And there's been a push towards that. And it seems to be a very viable thing. And there are a lot of good success stories in this. And going forward, we expect the wind and solar power to be a part play a larger part in the power structure of India. I mean, here in the power structure, I don't mean the political power structure, the actual electricity power structure here in India. So with that, let us thank Raj once again. Thank you very much, Raj, for being here and patiently answering all our questions. Some of them may have been very fundamental or very basic, but thanks for your patience and for your excellent explanations. Thank you.
Thank you, Raj. One thing is that, well, maybe when we share on social media, maybe you can put out in a various, I mean, maybe in few tweets, how India, as it is growing, how we are going to meet this energy demand. So maybe the power demand future, is in future.
I just want to add one comment, Suresh and Rajmohan. You know, if you followed this recent chess Olympiad, which India won, one of the most, one of the tensest things that happened was every player, Indian player, was worried about power cuts. And in fact, one of the preliminary matches we lost because two of the players had power cuts in their home. And in the finals, just before the finals, Anand learned that there was going to be some electricity maintenance near his house, and there was going to be a power scheduled load shedding, you know, from 1 p.m. or so when his match was about to start. So I saw a report where somebody had to call up some diplomat in London, Indian diplomat, who knew some officials in Chennai, officials, and they had to be told, please don't supply, please don't cut it, right? You need to maintain the power supply. So the point that it underscores is, you know, till the time that we can take it for granted, when I'm going to play the finals of a chess Olympiad online, unless I can take power supply for granted and internet connectivity for granted, I cannot count myself as a developed country. You know, and I hope that soon reach those levels. Thank you.
Thank you, Raj.
Thank you.
Thank you. So we'll sign off now. Thank you.
Thank you. Thank you very much, both of you, Suresh and Rajagopal. Thank you very much. Thank you.
Bye. Bye, Raj.
Bye.